This is a video demonstration for EE533's Lab 6, which is about the Bitfile generation of our mini ideas design, which we actually designed in the Lab 5 using the Xilinx IC tool. So let's get it started. So first things first, we have to follow the instructions provided by the professor. So we have to install the virtual box, which is running the Fedora 14, and it has all the necessary tools for the and it has all the actually the compiling tools for the NetFPGA so that we can generate the bit file. So we have to log into the switch to root user, head over to this directory netfpga/projects, copy the reference and make a folder called lab6, and then you head over to the synth folder and you hit the command make, which will help us in compiling and a successful generation of a bit file. Now and you'll see a screen like that. It'll go through all the processes like mapping, partitioning and all that, and it'll finally say make all. That means your reference router design bit file has been successfully generated. Now we have to compile our design, which was mini ideas, and generate its bit file for the NetFPGA, and this thing will be used in our future labs. So we have been provided with the folder called ideas.hw in the lab 5. So now we have to actually copy the contents of the ideas.hw to the lab 6 folder. So let's over. So these are the contents of the ideas.hw. So in here it has include src and hw folder. You need to copy everything over to the lab 6 folder. So I already have the src folder but it won't be there initially. You have to create a new folder for that and then copy your contents. Talking about the content, so in the src folder all your .v files of your mini ideas design should be there. So only these 8: bus merge, detect 7b, ideas.v, ignore this code gen right for now, the word match.v, comparator, drop FIFO, res9v, and user data path. So these 8. We don't need the verilog.v file for my dual port memory, because since it's an IP, it doesn't need a verilog file for that. We would need that IP cores file, but we will need the .xev one, and we will put it in the synth folder. So let me go back to here. We have to put the dual port memory, which is our IP core, in the format called xeo, in the synth folder. Same goes the rest. Since it already has an include folder, so the project.xml and the IDS, these two files will be overwritten. So initially these project.xml and the IDS files are of the reference routers, but now they'll be overwritten. But we'll go over that. So this is the first step: copy all your design files to the lab 6 folder, and now you head over to the synth folder and you hit the command make. I won't hit the command make because I'll just show you what possible hurdles we did face actually. So this was the first error. It says error 255, says it cannot find the definition of this module. So what we did was we used the command grep and we figured out where all this module is being defined. So there was one file called project.xml, which is in the include folder. Just look at that. Right. So in here, the nfpgA mac.group, this thing has been used in this file, project.xml.file. So what we did to fix it was we added this core slash IOQ slash ethernet.q, and this would fix this error. So these issues we face possibly because of the presence of true project XML files. So I talked about this earlier. There was a project XML file of the reference routers, and we also had a project XML file which was in the IDS HW folder. So we use the command diff where we compare the project.xml. Here the project.xml is my reference routers, and the project one XML is of my IDS hardware. So on the left side is all the IDS hardware project XML, and the right side, this right file is for my reference routers. So in here we figure out that in my reference router, uh, Ethernet underscore MAC was actually, you know, used. This yeah. So project one XML is of IDS underscore hardware. So in this folder, there is the presence of this line Ethernet underscore MAC, but in the project.xml, which is of my reference routers, this line wasn't present. And one more thing, the Ethernet underscore Q, this is the line we added to fix the error 255, but this file is only present in my project.xml, which is of my reference router. But since we overwrote the reference routers file with ours, this is why this line it wasn't there. So we just added this file, and actually we omitted one of this. We commented this Ethernet underscore MAC. Why we commented, because we figured out that in the error lines it was showing that there's some licensing issues, for that's why it we commented it. And a few more hurdles we face, like after after you make the changes in the project.xml file, you will face a few errors. So this is what we face. So these are like small ones, some naming stuff where things get messed up. Like it says, like in the ideas.b, which is a top module, verilog module, in here it had problem figuring out the date 7b. So, and even same goes for a drop FIFO. So make sure you name your files correctly, and the modules instances are also named correctly. So let me show you. Uh, so here ideas.b is definitely using detect7b and drop underscore FIFO. So but in here this wasn't the case earlier. The ideas.b was instantiating these modules, and here the B was uppercase and we didn't have the underscore, so there was a few mismatch cases. So make sure before changing, make sure you check your other file. So it says it's not able to figure out the definition of the module 7 uppercase B. So let me see how the module is being essentially made in the direct 70 file. So in here it's a lowercase b. So we will make the changes. Same goes for my drop before. Here there's an underscore. So these are a few mismatches cases which we need to take care of for successful bit file generation. And yeah, so now you go to the synth folder. Let me make it clean. And I hit the make. So the bit file generation goes through a lot of steps: synthesis, partitioning, placement, routing. So this would take a while, like probably like 10-15 minutes. And we are done. So as I said, after the successful bit file generation says made all. If we want to see the bit file, should be